So we will look at memory protection. In particular, we look at gates in this particular session because we were talking about different privilege levels, where I said the kernel will have the highest privilege level and the application programs are going to have the lowest privilege level. So if the application program wants to access some kernel services, it has to do through a process which is called as gates. We already saw how memory protection was going to be done. Whatever is the memory management unit examines the privilege levels in the DPL, the current privilege level and the requesting privilege level. If the RPL and CPL both are going to be lesser than DPL, only then access will be allowed. So that means virtually applications cannot access the interrupt, or you cannot access the different service routines which are available with the kernel. We said an exception is allowed. An exception is going to be allowed through gate. A gate is going to be the method by which a application which is running at the lowest privilege level can access data or procedure at the highest possible privilege level. There are different types of gates. There is the call gate, there is the interrupt gate, the task and the trap gate. So what we will try to see in this session is how the call gate works and the interrupt gate is going to work. Now, if you remember, the code segment or any other segment register will have the selector. The selector is going to point towards the descriptor. That is what is going to happen. The code segment points towards, code segment has a selector. The selector will be pointing towards the descriptor. Now this descriptor can be in the LDT or the GDT. So if the program that is trying to access the segment happens to be a low level program, or it happens to have the lowest privilege level, then what it does is it uses a call instruction, and this call instruction in turn will trigger a call gate. So how does it work? Similarly, when I say call, it's going to be a far call. So it will have the contents of CS and IP available in it. The CS is going to have the selector. Selector is going to have the descriptor, which will be either present in the LDT or it is going to be present in the GDT. So now, what is this descriptor going to be? This descriptor is going to be slightly different from the descriptors which we have seen. This is going to be called as a call gate. So this call gate is going to be a descriptor, but the format is slightly different. You are going to have 32 bits of offset, that is offset 0 to 15, 16 to 31. This basically gives you the offset value with respect to the start of the segment. That remains the same. Now there is going to be also the selector which is going to be available. Now instead of the base address here, there is going to be a selector. Now this selector in turn will point towards a descriptor. That is going to be the descriptor of the high level segment or the high privilege segment. So to start, whatever is going to be my application will be using a call instruction, which is a combination of CS and IP. CS has selector. Selector will be pointing towards a descriptor, and this descriptor is going to now be a call gate. The call gate will not have the starting address. Remember, a descriptor has the base address, it has the size, it also has the access right. But instead, what this call gate is going to have, instead of the base address, would be another selector. So the gate is a special type of selector. The gate descriptor can be in the GDT or it can be in the LDT. But instead of having the base address, it is going to have a selector. So this selector is going to be in turn pointing towards the descriptor of the segment. This selector points towards the descriptor. This is going to be the descriptor of actually the operating system's segment. So the advantage here you get is two levels of protection are going to be made available. So in the first level of protection anyway, the CPL and the RPL will be compared against the DPL of the call gate. So the current application will have a CPL. Whatever is going to be the selector will have an RPL. This CPL and this RPL are going to be compared against this DPL. Now there is another selector here. This selector is going to be having an RPL. This will be the highest RPL that will be compared against the DPL of the operating system segment. So the procedure is an indirect call. The call instruction will have CS and IP. CS points towards the selector. Selector points towards a descriptor which ends up being a call gate. A call gate doesn't have the starting address of the segment. Instead of having the starting address of the segment, it is going to have a selector. This selector in turn is going to be pointing towards the segment's descriptor. So this becomes a kind of indirect call. And you have two levels of protection. The first level is between the CPL, RPL and the DPL of the call gate. And the second level of protection is between the RPL and the DPL of the targeted segment. So this is how a call gate is going to work. So let's look at this procedure or try to write out this procedure again so that it becomes more clear to you. I will have a call instruction. A call instruction has code segment and instruction pointer value. Okay. Now this code segment is going to be having a selector. We know that segment is going to be treated as a selector. This selector will be pointing towards the descriptor. Descriptor can be present either in the LDT or the descriptor can be present in the GDT. So for ease, let's assume that the descriptor is going to be present in the GDT. So it will go to the GDT, it will get the descriptor. This descriptor is not an actual descriptor. Instead, it is going to be what is called as a call gate. So what is the difference between a descriptor and a call gate? The descriptor has the starting address of the segment, but the call gate does not have the starting address of the segment. Instead, it has another selector present in it. So while this is being done, of course, memory protection is working in parallel. Whatever is the program will have the current privilege level. The CS will have the RPL. The CPL and the RPL will be compared against the DPL of the call gate. If the CPL and the RPL happen to be at a higher privilege level, then the call gate is accepted. Otherwise, the call gate will not be accepted. So for example, let's say the CPL happens to be 03 and the RPL is going to be 02. Now the lower privilege here of course is going to be 03. That is going to be taken by the system. And if the call gate has a DPL of 03, then it means that it is allowed to take this call. If it is going to have a DPL, let's say 01, then it is not allowed to take the call because 03 is a lower privilege when compared to 01. So it will not be allowed to take the call under these conditions. So continuing, selector points to descriptor. Descriptor is the call gate. Call gate has another selector. This selector points towards the descriptor of the destination segment. So this is finally what points towards the descriptor of the destination segment. So here you will get the address of the program segments or the operating system's segment. So the procedure is not direct. The normal procedure was the selector will be pointing directly towards the descriptor which has the base address. This is the normal procedure. But in case of a call gate, you have a call instruction which will have code segment and instruction pointer. Remember, the only type of call that you can use here is a far call. You cannot use a near call. If you use a near call, the code segment is not going to be used. So it has to be a far call. The code segment has the selector value. The selector will be pointing towards a descriptor in the LDT or the GDT. This descriptor turns out to be the call gate. The difference between the call gate and the normal selector is going to be the call gate is going to have a selector inside it instead of the base address. This selector points towards a descriptor. This descriptor is going to have the base address. So this is going to be at 2 levels it is done. Protection is going to be more. This also ensures that any application can access these services which are provided by the operating system only after going through at least 2 levels of check. So there is no arbitrary access of the operating system's function or the operating system's data. So that is the advantage that you are going to get here. Now this is going to be how the call gate is going to be working. There is one more type of gate which is going to be the interrupt gate, which is essentially involved with the interrupt instructions or any exceptions or errors that might happen. Whenever there is an interrupt or an exception, what is going to be used is not the LDT or the GDT. For call, LDT or GDT is used, but for an interrupt, LDT or GDT will not be used. Instead, the interrupt descriptor table will be used. You have already seen this with respect to the interrupts. The interrupt number will be taken. Let's say the vector number of the interrupt happens to be 10. So in this case, 10 will be multiplied by 8. It gives 80, and this is going to have the pointer towards the entry in the IDT. What does the IDT have? The IDT will not have a descriptor. Instead, the IDT has a gate. This gate will have a selector. This selector in turn will point towards a descriptor which has the base address of your interrupt service routine. So this is what happens for interrupts in the protected mode of operation. Vector number multiplied by 8 points towards the entry in the interrupt descriptor table. So if it is 10, it is multiplied by 8. So it means that it is going to be at entry 80H plus your base address. The IDT will have a base address. So the base address of the IDT will be added with 80H, and this will have a gate descriptor. The gate descriptor will have a selector. The selector points towards a descriptor. That descriptor will have the base address of the interrupt service routine. So again here there are 2 levels. You first access the IDT. IDT gives you a selector. The selector gives you a descriptor. So at level 1 IDT, the next level you are going to have the selector. Selector gives the descriptor, which is the base address of the ISR. So even if you are using an INT instruction, there is going to be 2 levels of protection that is available. So this is how any kind of application which has a lower priority can access a operating system function of higher priority by using either a call instruction which will have the CS and the IP contents, or using an interrupt instruction with some vector number associated with it. For example, I can say interrupt 80H. So this is the way by which an application of lower privilege is going to access any program segment or data segment which is going to be available with the operating system. So these are the call gates and the interrupt gates. As I said, trap is a type of interrupt, so I'm not going to go into detail of the trap gate. What we will see in the next 2 sessions is how the task gate is going to work and how task switching is going to be helped by the memory management unit. So what we have seen so far is going to be how memory management unit does virtual memory functions. We have also seen how memory protection is going to be enabled by the memory management unit. What we will see next is how task switching is done by the memory management unit. These are the 3 functions that are carried out by the MMU of 80286, 386 or 486. So I'll stop here in this session.